Hi students, in this video we are going to discuss another minimum cost spanning tree algorithm, that is Prim's algorithm. In the previous video we discussed one algorithm to construct a minimum cost spanning tree, which is Kruskal's algorithm. Now another algorithm is there, that is Prim's algorithm to construct a minimum cost spanning tree. So, what are the steps involved in this? For this, consider a graph which is weighted. Consider a weighted graph. Okay. Now, for example, this is the graph A, B, C, D, A, F. For example, this is the graph and the weights here are 3, 2, 6, 4, 1, 7, 5. This is the graph. So, for this, how to construct minimum cost spanning tree by using Prim's algorithm. For this, we have to represent weighted table. Weighted table or weights table. For this, what are the columns present in this graph? First, we have to consider the vertices, what are present in the graph, and whether that vertex is visited or not, and what is the weight of that edge or cost of that edge. You can consider this. This is a weighted table which consisting of this. Vertex. What are the vertices present here? A, B, C, D, E, F. Initially, no vertices are visited. Here you can take weights or distances. Okay, distances. And this distance is from which vertex? From the vertex. From the vertex we will represent like this. From the vertex. Initially we don't know the distances, we have not visited, that's why all the distances we will consider as infinity. Okay, next, from the vertex. From which vertex? We have not yet visited, no? So this is initially, you can take weighted table or you can take this as a distance table. Okay, so this is the initial configuration of the graph, distance graph. Now, what is minimum cost spanning tree? The total cost should be minimum. Minimum cost spanning tree means total cost should be minimum. Now, consider start from any vertex. For example, I am starting from the vertex A. So, make that vertex as visited. Now, from here we will represent another table. Here I am representing. This is step 1 and this is step 2. Vertex visited or not, distance from the vertex. Now, what are the vertices present in the graph? A, B, C, D, E, F. Okay, we are starting from vertex A. So, that means that vertex is visited. So, 1. Then, from that vertex to itself, the distance is 0 from the same vertex. Okay, so now find the adjacent vertices for A. A vertex adjacent vertices are B and C. What is the distance already B is having? Infinity. C is having infinity. Okay. Now, what is the distance now from A? It is 6 units to B 3 units. So, already you have infinity. Now, A to B distance is here how much? 3 units. So, now A to C distance is 6 units. Compare with the old distance. Old distances here are infinity. So, 3 is less than infinity, 3 is less than, 6 is less than infinity. That means new distance is less than old distance, then update the distance. Otherwise, no change. Otherwise, no change. Okay. Now, say, so see again, if new, this is very important, new distance is less than old distance, then update the distances, otherwise no change. Okay. So now, see, now this is the condition we have to remember. So now A to B, the distance is 3 units. From which vertex? From the vertex A. From A to C, what is the distance? 6 units. From which vertex? Vertex A. Remaining all these vertices are not visited, and write those values as it is. Infinity, we don't know. Infinity from the vertex, we don't know. Now third one, third step. Again the same table, vertex, visited or not, distance from the vertex. A, B, C, D, E, F. Okay. A vertex already visited, write down that as it is. Okay. Next, which vertex we have to visit? Find the shortest distances. From all the shortest distances B. So that's why visit B vertex. That's why make that visited vertex value 1. Okay. And the distance no change, 3 units from the vertex A. Okay. Next, we have visited B vertex. That means these vertices are unvisited. Now, find the adjacent vertices for B. B adjacent vertices are A and F. But A is already visited. Here you got 1. So, F is not visited. F already distance is infinity. So, we will compare 7 and infinity. 7 is less than infinity. So, for F, B we have visited na? B, yeah, it is 2 units, not 7 units, 2. So 2 is less than infinity, so 2. From which vertex it is 2? From the vertex B. That means remaining are as it is. Remaining are 6A, infinity, infinity. Okay, that is third step. Now coming to fourth step. Vertex, visited or not, distance from the vertex. Okay. A, B, C, D, E, F. So, in this distance table, already visited vertices, rows write down as it is. 1, 3, here it is A. Now, from all these C, D, E, F, which vertex we have to use it? Which vertex is having less distance? 2 units is the less distance. That's why we will visit F vertex. So make that vertex visited value 1. It is 2 and here it is B. Now remaining all are unvisited. Write down unvisited. Okay. So now from the unvisited vertices, that means C, D, E, which one is having shortest distance? C. Now we have visited F vertex. F vertex visited value 1. So F adjacent vertices are B, C, E. B is already visited. C and E are not visited. So to C vertex, what is the distance here? The distance here, it is 7 units. Already to C, what is the distance? 6 units. So new distance is greater. That's why we will not update. So A6 we will write, and here it is A. Next, F vertex adjacent vertex is B we are not considering. Why? Because that vertex is already visited. Okay. So for F, the adjacent vertex is E. E, the distance is infinity, and here it is 5. So 5 from which vertex? F vertex. D vertex is as it is 0, infinity and dash. One, two, three, four. Now, fifth step. Same vertex, visited or not, distance, and from the vertex. So A, B, C, D, E, F. Remember, already visited vertices rows, write down as it is. This is A visited, 1, 0, no. So this is also visited, distance is 3 from A. This is already visited, this is the row. Now, from the unvisited vertices C, D, E, that means see here we are having zeros. That's why from the unvisited vertices, which one we have to visit? So 6, infinity, 5. Which one is small? E is smaller. So visit E, and the distance is 5 via F vertex. Now find out E adjacent vertices. D and F. F already visited. Find out D. E to D distance is 1 unit. Distance is here infinity. So here it is. These are unvisited. This is 1 unit. From which vertex? Here it is. Which one we have visited now? E vertex we have visited. From the vertex E. Okay. Now C vertex is as it is. 6. A. Now next step, same. V, Vi, distance from the vertex. A, B, C, D, E, F. Visited vertices, write down rows as it is. 1, 3, A. E, 1, 5, F, 1, 2, B. Now from these two vertices, which one is next to be visited? D. Why? Because the distance is 1. 1 is less than 6. So visit D. So make that vertex visited value 1. And here it is 1. That row is as it is E. D adjacent vertices C and E. E is already visited. So visit C. See what is the distance here? 4 units. So 4 units. From which vertex it is? D vertex. Okay. So now 6th step completed. Now 7th step. Vertex BI, distance from the vertex. A, B, C, D, E, F. Okay. So 1, 0. Visited vertices rows write as it is. Okay. D, 1, 1, E. 1, 5, F. Next up, from the unvisited vertices, which one we have to visit? C. 1, the distance is 4 units. This is, yeah, this is the distance table we got by using Prim's algorithm. What we are doing? We are starting from any vertex. Find the adjacent vertices. So visit, what we have to visit? Visit the shortest distance vertex. So like that you have to repeat until all the vertices are visited. Now how to represent a spanning tree for this? So first we have to represent a spanning tree. Spanning tree means here first we will write as it is vertices like A, B, C, D, E, F. Now from here we will represent them. A to E, there is no edge cost now. See, A to B, start from B. From which vertex? A vertex. From A vertex A to B, the cost is 3 units. This one completed. Next, from vertex D to C, 4 units. D to C, 4 units. This one completed. E to D. E to D, the distance is 1 unit. Next, F to E. F to E, the distance is 5 units. B to F, the distance is 2 units. Total cost or minimum cost equal to 3 plus 2 plus 5 plus 1 plus 4 equal to 3 plus 2 5, 5 plus 5 10, 10 plus 5 15. 15 units is the minimum cost for the given graph, given weighted graph. Okay, first what we have to visit? First we have to consider the initial distance table, then start from any vertex and find out adjacent vertices for that vertex. Then next, which vertex we have to visit? So which one is the shortest distance vertex, that we will visit. Like that you repeat the process until all the vertices are visited. So this is Prim's algorithm. Hope you understand, students. If you have any doubt or for any graph, if you are unable to construct a minimum cost spanning tree, please send me that graph. Okay, then I can clarify your doubt. Hope you understand. So if you have any doubt, please don't forget to send a message in the comment box. If you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day.